Okay, so like I said, we're talking about Python errors and error handling or exception handling. Both mean the same thing. Okay, so let's suppose we had a program which started off with this statement, val equals 5. All right? Okay, well, if I typed this next statement, okay, you all can see that I did something wrong. That's fine, but sometimes this is a common thing that people do. They mess up their types. In other words, so I actually made a little error in this particular statement. But let's just, there is an error, but let's just run it anyway and look a little bit closely at the error message. Okay, so when I run this, of course, I get an error message. You knew that we would. And if you look at the bottom line of that error message, we see the word name error. Okay, there are different types of errors, different categories of errors that occur in a Python. One category is a name error. And of course, it's showing us that the errors in this statement. And it says that the name val is not defined, okay? And of course, at this point in the course, you know that the reason we're getting that error is because there's no variable. We're trying to print val starting with a capital V, and there was no val with a capital B given a value here, okay? So Python produces, okay, produces an error called a name error when there's a name, when an access is made to a variable that doesn't exist, okay? And a name error, so whenever you see name error in your error message, it's usually something, well, it is something that is your fault as the programmer, and it's something that you can edit your way out of. Okay, so a name error is raised, okay? I'm just going to start using terminology here. When an error occurs, you say an error is raised, okay? So a name error is raised when a variable that has not been created is accessed, and of course, this can be fixed in the code. Okay, so, and of course you know that we can fix that by, I could have fixed that just by using a lowercase b, right? We all know that, okay? So name errors can be fixed in the code. And whenever you see an error message that says name error, you pretty much, you know it's something in a name. You named something wrong, you either misspelled it, you used the wrong case, or you might, sometimes you get a name error if you didn't import something that you were supposed to import because it doesn't know what the name is that you're using. Okay, so that's one category of errors. Another category, well, let's look at another situation here. Let's suppose we have a variable dollars, and let's suppose we have a variable cents. Okay, and let's suppose I wanted to print out this amount. And I wanted to, let's suppose I was trying to print it out so that it would look like money. In other words, I'm printing out, in other words, I printed out the word amount with a dollar sign, then I printed out the number of dollars, then I printed out a decimal point, and then I printed out cents. And this was me attempting to make it look like money, all right? Okay, so that's a nice attempt, but let's see what happens. Let's see if it works, first of all. Okay, it runs. I'm not getting an error, but it's not printing out the way I wanted it to print out. I wanted it to print out nicely, looking like dollars and cents, and I have these blanks here. Okay, so you know why, again, seasoned Python programmers, you know why I have those blanks there. What's the problem? Why do I have those blanks there? What's causing those blanks? A comma. Whenever you have a comma in your print statement, you get a blank. Okay, so let me try to change this then. We know if if we get rid of these commas, we're basically going to have to provide one great big string to the print function. Okay, so I got rid of the commas here, and I just replaced them with pluses. So I'm trying to build one great big string by concatenating a bunch of stuff together. Okay, so that sounds reasonable. If I have one big string, it's you know, there aren't going to be any additional blanks stuffed inside. So when I run this, let's see what happens. Okay, now when I run this, we got an error, and again, we're going to see a lot of errors tonight because what we're talking about is errors. And so we see an error, and rather than being a name error, as in the last segment, it's called a type error. Okay, the type of error that was raised was a type error. And you get a type error when you're using something, using a variable in the wrong situation, or using a variable in a context for which it is not the right type. Okay, remember we talked about how different variables have different types. Okay, everything has a different type. And so, tell me, how can I, so, and it says, must be string, not int, and it's kind of looking at this statement. Something in here should be a string and not be an int. Well, we have two ints here, right? Dollars is an int, and cents is an int. So it's telling us, yeah, it must be a string, not an int. So, so what do I need to do? What do you think I need to do to fix this? Yeah, I need to convert these two. I need to convert these two ints to strings, because I can only concatenate strings together, and I can't concatenate a int to a string. Okay, so I can fix that. Okay, so type error is raised when an attempt is made to use a variable in the wrong context for its type. Okay, and again, we put the str there, and that's going to fix it. So this can be fixed in the code. In fact, I did just fix it. Okay, we'll run this to verify that. But yeah, but now let's run it again, so it's up near the top of the screen. But again, when we ran this, it worked the way the intent. Okay, it looks like dollars and cents, and that was the intent of that little segment there. Okay, so far we've seen two different types of errors that can be raised by Python when things are wrong, and both of these types of errors are things that when they happen, we can look and we can see what we did wrong. They're both actually programmer errors, right? Programming errors, and we can fix them. Okay, so let's look at another type of error that can occur. Let's suppose I have, let's suppose I have a cost, some sort of a cost, some sort of a price. I'll assign $10 to that variable cost. And let's suppose I want to apply tax to this cost, and I'm not sure what the tax amount is, so I'm going to ask the user to enter the tax percent. Okay, and I'm going to tell them, yeah, it was something like 5. So if it's 5%, I want them to enter 5. If it's 8.5%, I want them to enter. I don't want them to enter 8.5. Whatever. I want them to give me the number. what the tax rate is. Okay, and then of course the next thing I would go on to do in this program probably is calculate the total cost with tax, which would be the cost plus the cost times the tax amount times 0.01. Okay, or I could divide by 100 either way. Okay, so basically here's the cost plus the tax. I've just calculated that and print out that total cost. Okay, so very simple. We have a cost. We ask the user what the tax amount is, what tax rate is, calculated the cost with the tax, and then printed out the cost with the tax. Okay, or some pretty simple statements here. Okay, so let's see what happens when we run this. Okay, let's see. Okay, well, enter the tax percent. Okay, and I'm going to enter 8. So I think, yeah, the total cost is $10.80, which would be correct if there was an 8% tax on $10. Okay, so that seems to work. That's great. Okay, that works. I'm going to run it one more time. Now, the second time that I'm running it, I'm going to be the typical user. Now, users, you know, I mean, you've probably sometime in your life on the computer entered something into a program, and it maybe wasn't what the program expected you to enter. You know, they might be prompting for something and it wasn't that clear, or you didn't enter the right thing, or you mistyped. Something like that can happen. So it's quite likely that somebody looking at this thing see the tax percent, and they see the word percent is there 5, and so who knows? I'm looking at this and I'm thinking, oh, they want a percent, they want another percent. So I'm typing percent and I'm typing 8. Okay, so I type that. Okay, in response to that question. And what happens? Oh my gosh. Okay, we get another error. An error is raised. It's not a name error like we saw in the first example. It's not a type error. Okay, it's a value error. Okay, and a value error happens when a value is not of the correct, what do I want to say, in the correct form, I guess, that needs to be used. Now here, what's going on, okay, is, okay, the string %8 was read in as input, okay, and then that was passed to the function float, and float is trying to convert %8 to a floating point number. Well, if you think about it, the only characters that are valid for floating point numbers are digits and a decimal point, right? Those are the only things that should be in floating point numbers. So when the float function was trying to convert this string, okay, to a float, the first thing it saw was that % sign. It said, I don't know what that is. I don't know what to do. I can't convert this. So the value error was raised. Okay, and it was actually the float function that produced that error. Okay, and we're going to see a little bit later how functions produce errors. So basically, this float thing caused the error. That float conversion could not happen. That's why we saw that message. Now, unlike the other two examples that we've seen, there's nothing I can. Right here we have. Let's see. Value error may be raised. Okay. Unlike the other two examples, there's no change. There really isn't a change I can make to this code. I could, if I was feeling really adventurous, I could actually read the tax amount in as a string and look at each character myself and check one character at a time, just make sure it's a digit or a decimal point, make sure there's only one decimal point, and I could write a very complicated function to do that. But if I wanted to just read it and convert it as a float, there's nothing I can, there's nothing in the code that I can change to prevent that value error from happening, okay? So what we're going to do instead, we know that right here, a value error could occur if the user types the wrong thing, right? So what I'm going to do is I'm going to place these statements in what's called a try block, okay? A block being what? A block being just a bunch of indented code, like when you put you know, those statements inside of a while. That's a while block. That's why I'm calling this a try block. So these three statements are inside of this try, just like when you indent statements in a while or indent statements in an if. The statements that you indent are part of the if, okay, or the while. Now, when you have a try block, that tells Python, watch for an error. In other words, it tells it, watch for an error that might occur when any of these statements are executing, and if any of them, if an error happens, if an error is raised, okay, instead, stop executing, stop whatever you're doing, and execute what is down here in the except block. Okay, yeah. Okay, so again, the way this is going to work, okay, try means to look for something. So when you get a try there, Python's on the alert. Python knows, okay, in any of these statements are indented here, I'm going to be looking for an error. And if the error is raised, okay, be it a value error or any other type of error, there's other types of errors. If any kind of error occurs, when these statements execute, I'm going to stop what I'm doing right at that point and come down here and execute this. So in other words, right here, the user entered that %8, right? And float could not do the conversion, and that value error was raised. Right at that point, the control would jump right down here and print this. These two statements would not be executed. Okay, I'll jump right down here and do this instead. Okay? So that's how the try except works. Try means look for it. And whatever had happened, I have to do whatever's in the except block instead. Okay? Okay. So, now, if you run your program, now if you run your program and you type in that %8, you should, you're not going to get red. You're not going to get a red error message. Okay, your program basically you didn't get a red, awful thing with your program stopping. You actually got a nice little error message put out by the program, and the program ended, but that was because there's nothing else happening. If there was more to happen in the program, if there were more statements to follow, the program would continue. Okay, so what we did here was we handled the error. Rather than the error spewing out on the screen and all red and stopping our program and causing a panic, we handled the error nicely. There's different ways you can handle errors. But we handled it nicely, and the program could have, had there been more statements in this program, could have continued on gracefully. Okay, so we recovered. Now, as I just said, there are different ways to handle errors. Here, actually, the way I did it here, I just gave an error message, but maybe, I'm going to move some statements around here, actually. Maybe I want to handle this situation a little bit differently. I'm going to move these two statements out of the try block, actually. And I'm only going to place this one statement that I know is causing a possible value error in the try block. And what I'm going to recover in a different way. I'm going to put some other things in my except block. I'm going to tell them there was an invalid character. 5% tax rate is assumed. And I'm going to put a 5 in there. Okay, so this is going to work a little bit differently. So it's just a different way of recovering. Before I just gave an error message and didn't calculate the cost. Here, if this error occurs, okay, again, right away it'll jump down here and execute what's in the except block. And what the except block is just going to do, hey, there's an error. I'm assuming 5%, and it'll put a 5 in tax amount, and then the calculation will be done, and the cost printed. So if we run it now and give it erroneous input, we should get $10.50 as our total cost. Let's see. So I'm going to put that %8 thing in again, and again, we see, yeah, it told me, yeah, there was a valid thing, but a different tax rate was assumed, and then I got a value there. Okay, so the idea is it's all about recovery. It's all about catching an error. The try block is actually called, sometimes it's called catching an exception or catching an error. And you catch it, and then you catch it when it happens, and then divert the program flow to what you want to do, what kind of recovery you want to do. Okay. In this situation, sometimes the recovery is just giving an error message so the program doesn't crash and spew out red stuff. Sometimes the recovery is substituting a different value. Whatever the idea is, catch the error so that the program can recover and continue on nicely rather than just giving big red stuff on the screen. Okay, is there any questions about anything we've done so far? Okay. Let's look at something else. Let me move this up. Let's see one more example. Let's suppose I have a list. I called it name list. I'm going to put 3 names in it. Okay, so my name list has Bob, Sue, and Roger in it. And let's see, what do I want to do with this name list? I want to, again, this isn't anything deep and complicated. It's just meant to show how things work. So what I want to do in my name list is I want to ask the user, to, there are 3 names in the list. Which do you want to see? And I want the user to enter a 1, 2, or a 3. So in other words, if they wanted to see the first, if they wanted to see the first name, they'd enter a 1. If they wanted to see the second name, they'd enter a 2. If they wanted to see the third name, they'd enter a 3. Very simple. And then basically, I will print out using indexing. I'll print out what they want, what the entry that they wanted to see. And if they said they wanted to see entry number 1, of course my list is indexed starting at 0, so I'm subtracting 1 from item number. Right? If they said they wanted to see the second thing in the list, 2 minus 1 is 1, which is the index of the second thing from the list. And same thing for the 3. So whatever they entered, 1, 2, or 3, I'm subtracting 1 before I use it as an index, just because of the 0-based indexing of the list. Okay? Okay, so let's see what happens here. Let's run it. Okay, let me start with a new interpreter, so it comes up high on the screen. Okay, so run it. We have this tax rate thing. Okay, and now there are 3 names in the list. What do you want to see? And if I enter a 2, I think I should see the name Sue, because that was the second thing in the list, and I did. So that works. Terrific, that works. Okay. But now, let's run it again. And if we run it again, let me get past this tax rate example. There's 3 names on the list. What do you want to see? It's telling me 1, 2, or 3, but clearly I can't follow directions, and I'm typing 4. And so what happens? Because the user doesn't always follow directions, and in this case, if the user doesn't follow directions, the program crashes, and we get an error. Okay, get a Python error. And nobody, you never want the person running your program to have to see this kind of stuff. So you always want to kind of guard from that happening however you can, and that's what exception handling is all about. You catch it before it comes out spewing out on the screen. You catch the error and you handle it before it spews out on the screen. So here we have a index error. So it's not a name error, not a type error, not a value error. It's an index error, which happens when you're indexing something, be it a string or a list or a tuple, and you're using an index that's invalid, that doesn't exist in your structure. Okay, so I have an index error. Okay, and again it shows me the statement, and it's fine. But again, this isn't something I can program my way out of. Okay, I guess I could. But I'm not going to. I guess I could. One way I could program my way out of this is to put a while loop around this input thing, right, and just keep repeating while it's invalid. I could do that. I'm not going to do that for the sake of this example, but I could program a loop. But so another way I can do it, another way I can fix the situation, okay, is I can put. Let's see. I'll put both these statements in it. I can create a try block and have Python looking for an error. And I can have an exception block. And the exception block is going to, let's see, again, I know a index error might occur, so I'm going to print out here index out of range. And I'm even going to tell them what the bad index was. Okay. And then, just like we saw before, again, I'm just printing this out. I could substitute something else. There's actually a number of things I could do. But at any rate, I'm just going to keep it simple and just tell them, yeah, there was a problem, and this is the bad index. And of course, if we run this, now if we give a bad index again, I'm going to give it index of 10, and instead of getting red stuff on the screen, I get index out of range. Index is 10, okay, so which is sort of, looks a little bit nicer. At least it was gracefully telling me I did something stupid, as opposed to red lines all over the place, which is not something that's understandable by a typical user. Okay, so this example is sort of like the one above, right? We have the same idea. We knew something was going to, separate those two. We knew something was going to happen. We knew an index error would be, if they didn't enter 1, 2, or 3, that we were going to get a index error, and we have an exception block right there. Now, does that make sense to everybody? Okay, now you tell me, looking at that try block that I just created here, yeah, an index error can occur. There's another type of error that could occur in those two statements. What other type of error could occur? Actually, not a type error, but a value error. What if the user had entered, instead of, I tried a 10 and a 4, what if the user had entered we'd asked for 1, 2, or 3, and they'd entered A, then what would have happened? The int function would not have been able to convert that A to an int, and we'd get a value error. So there's 2 types of errors that can occur. Now, we're in a way we're okay here, but let's just look and see what happens. Let's try that. Type that A and see what happens. I mean, we're okay that we're protected, but I'm going to type in A. Okay, instead of 1, 2, 3, I'm typing A. Oh, wait, what did I do? Hold on. What did I do? Oh, maybe I did it for the wrong one. Let me check. Okay. 3 names. Actually, that surprised me. Hold on. Do I have something else wrong in here? I'm thinking, because it shouldn't, right now, I'm not, it should just, let me take this, let me not print out the item number. Okay, just for a moment, because I want to point something out. So I still have that except block there. And if I type in an A, again, if I just type in A and I'm not trying to print out the item number, my except block's still grabbing it, because my except block is going to grab any kind of error that occurs. I was getting that red stuff before because I was actually down here trying to print out item number, and if the error occurred in the input statement, if the error occurred up here, item number wouldn't have a value when it got down here. Okay? But now the thing is, so basically I'm getting down here in this exception block with a value error or an index error, and I can only take one action, and I probably do want to take different actions. I probably want to do one thing. If there's a value error, I might want to do something else if there's a index error. Okay. In particular, if there was an index error, I wanted to print out the bad index, which I don't want to do if there was I only want to do this if there's an index error, not if there's a value error. Okay, so this is what I want to do if there's an index error. So what I can say, when I say except, I can also tell what kind of error the except block is reacting to. Okay, so if I say except index error, this is only going to execute if it was the index error that caused the problem. On the other hand, if it was a value error, I can indicate that the maybe I just want to, let's see, invalid character, list will be printed. Maybe that's what I wanted to do. I mean, I can do whatever I want, however I want to recover, however I want to continue on, I can do that. Okay, so I can have multiple except blocks, okay, and specify for which error each except block is going to execute. So now if there's a problem with the int function call, it's going to come down here, okay, and print out the whole list and tell them there's an error. If there was a problem with the indexing, it's going to tell me there was a bad index and report on what the value of that index is. Okay, so either of those errors should be handled by our code, but they'll both be handled differently, 1, 2, or 3. So if I say A, I'm seeing an invalid character and the list is printed. On the other hand, if I had typed a 10, it would have said index out of range 10. Okay, so is everybody's doing what we, let me run this one more time with the other error. Okay, I'll come over it. Okay, so So here we see both error then. In this situation, it asked for 1, 2, or 3, I typed A, and I got 1 error. In the other situation asked for 1, 2, or 3, I typed 10, and I got the other except block executing. I think, wait, was that, is that one, did that happen when you executed it? Oh, we have to have the other one too. You want to have it right here. Yes, okay, because here, if you say accept, and this is interesting. Yeah, right here you want to put the index. And actually, this is interesting. The error he had put this value error here, he hadn't put index error up there, so it just said accept. And accept without an error will grab any kind of error, will fix any kind of error. And if you just have an accept by itself, it can't be before another one because it's only going to do one of the exception blocks, okay? So if I have accept before I have value error one, that's kind of a logical error because it checks this particular type of error first, so it would actually try to do this for a value error which never gets down there. So the idea is if you want to have an accept all by itself, that handles anything, you put that one last as like a catch-all. Like right here, let me show you what I mean. The way Python does this is if an error occurs, okay? If an error occurs in this block, Python's first going to check, oh, is it an index error? Okay, and if it is, it'll execute this. And if it's not, then, oh, is it a value error? If it is, it'll execute this. If it's not, well, at this point, it won't do anything. It'll just go on with the program, but I probably want to have a catch-all. By catch-all, I mean a third variation, except. Now, if I don't say what kind of error, it just means, well, if you get down this far and there was an error, this is what you're going to execute. So if there was an error and it wasn't an index error, and it wasn't value error, then this last except block will happen. But if you want to have an except all by itself, you have to have that last, so it checks all the other ones first. Does that make sense? So it's sort of like when you have an if, else if, and an else down at the end. You know, that else at the end is catching everything. Okay, so is everybody's working? Yep. Okay. Okay. So now we've basically seen how to we've seen how to catch a number of errors, and actually there are a number of we've seen how to catch, I think, 4 different types of errors, or 2 in particular, and how to catch other types of errors. And I think when you read your chapter this week, it gives you a little grid of the different types of errors that can occur. There's another error we'll look at in a little bit that occurs if there's a file problem that we'll look at last. But you know how to catch an error. You got to try for it, okay? And then you write an except block to do what you want to do if the error occurred. It's pretty straightforward, okay? Now, I would like to save this file because you're going to submit that file, okay? And we're going to start a new file. We've seen how to try for exceptions, grab them, and then handle them, okay? And these are all the exceptions that we grabbed and handled are exceptions that Python raised, all right? Python created that value error. Python created that, told us about that index error, okay? It is also possible to create your own error, okay? to create or raise your own error in some code. So let's suppose we wanted to, let's suppose we were going to write a program which created a list list of numbers, okay, and then allowed the user to enter a value, and it would change this list by dividing every element in the list by that value. In other words, let's see. In other words, we're going to tell the user, enter a value, each element in list will be divided. In other words, if the user entered a 5, my list is going to change to 1. I should have picked better numbers. Let's see, just so I can give you an example of what I mean here. It doesn't matter what the numbers are. I'm just so I can give you an example of what it's supposed to do. If the user entered a 5, my list is going to change to 1, 11, 2, and 20. In other words, the list will change. Every element in the list will be divided by that divisor. Okay, that's what the program's supposed to do. It's supposed to update the list. Okay. 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 So now on each. So list. Now the list will be updated, putting in comments so you can kind of figure out what I'm doing here. So now what I want to do, okay, for I in range len a list. Okay, so if I say for I in range len a list, the length of a list is 4, so I is going to take on the values 0, 1, 2, and 3, which are all valid indices of the list a list. Okay, and what I want to do for each a list at, basically for each a list at index I want it to be assigned a list at I divided by I. Okay, I mean divided by divisor. Okay, now to make, just for this example, I could easily do the calculation here, a list at I divided by divisor. I could easily do that. But rather than do that, I'm going to pretend that I have a function called divide that takes a number and takes the thing I want to divide it by, does the division, and returns the quotient. Okay, so in other words, what this function is doing is this. And yes, I could have just done that, but I'm trying to show something about errors here, so I'm going to keep the application pretty simple, but so to keep the function simple. So I'm calling a function on each element. Okay. Now, if I'm calling this function divide, and there's not really a function, obviously I have to define the function. So I'm going to define divide, and divide takes 2 parameters, a and b, and it's going to basically, it's going to do that. It's going to return a divided by b. Actually, yeah, that's fine. Okay. So now you tell me, in what situation will dividing one number by another cause a problem? What can't you divide? What can't you do with division?
Divide by 0.
Right, you can't divide by 0. So now, forgetting about the main process for the moment then here, just looking at divide. Divide has this job. And functions always have their own little job, their own little task that they're supposed to do. And they're not supposed to be thinking about how they're called, where they're called. They're just supposed to do their one little task. So, that's the logic in writing a function. That's kind of the beauty of writing a function. You only have to look at that one little piece when you're writing it. So if all I have to do when I'm writing this function is divide a by b, that's pretty simple, except again, if b is equal to 0, I can't do it. I know if b is equal to 0, this will crash, okay, because you can't divide b by 0. So, you can't divide anything by 0. So, I'm going to, and if b is 0 and I can't do the division, I don't really know what to do. My job is not to worry about what the main program's doing or how to fix it or prompt the user or do anything like that. My job is just to divide one thing by another and return the answer. So, I don't know what to do if b is 0. So since I don't know what to do, what I'm going to do is I'm going to say if b equals 0, I'm going to raise a value exception, a value error. Okay, I'm even going to say divide by 0, attempted. Okay. Otherwise, return a divided by b. So the way this is going to work, okay, when you raise an exception, what happens is that exception is thrown back, is given back to where the function was called. Okay, so if this function is called with b being 0, the execution, this will be true, the execution will, this statement will execute, and basically a value error will be sent back to where the function was called. Okay. If b is not 0, the quotient is returned. So I'm raising my own exception. I'm creating my own value error exception because there's an error with the type of value. That's a good type of exception. It's not a name. I could raise a name error. I could raise a type error, but none of those really make sense. It's the values. The value's logically not correct for what I'm trying to do. So I'm raising a value error. Okay. So now, let's look back at the main process and follow the logic we were following in the other file. I have a situation where I'm calling a function, divide, that might raise an exception. Right? Okay, so this might raise a value error. Okay. Now, okay, that might raise a value error, so what do I want to do? I want to be prepared for a value error when this is executed, whenever this statement's executed, okay? And I want to, and I could prepare for that by putting it in a try block, okay? So, let's see. Oh, okay, so I'll put this in a try block. Put my whole for loop in a try block. And if there was an exception, if there was an exception any time and any call to divide, what's going to happen? The second that exception was raised and divide sends it back to right here, the control is going to jump down and execute whatever's ever in my except block, and that will be the end of the for loop there. So I'm going to print can't divide by 0. Okay. So there's nothing different here from what we were doing in the other file, except, I have a try block, I'm waiting for a exception that I know could happen. It's it depends on what the user does. And so I can't code around it. And if the exception happens, I have an except block that's going to execute. The only difference with this scenario between this and the file that we just had is that we wrote the code that's creating the exception. Python didn't, right? We're saying that we're raising the exception. So now, of course, the way this should work is if when you run it, you give a nice value, like 5, okay, I didn't print out the list when I was done, but I don't get an error, okay, and it would have changed all the values in the list. On the other hand, if I run it and I say the value that I want to be dividing into is 0, I can't divide by 0, okay? And again, I would have gotten red, I would have gotten a red Python error had I not handled that. Actually, if I hadn't, I probably should have done this. If I had raised this exception with my divide and not put in the try except, I probably should have done that. We would have gotten a red, a value error was raised. We happened to raise it, Python didn't, but we would have got a red error message, okay? But again, same situation, we waited for it, watched for it, and handled it, okay?
What's the reason for us raising the error instead of voting?
Because we were writing the code where there was a situation where there was going to be a problem, and we didn't, in writing this function, we didn't know what to do. Okay, we didn't know what to do if b was 0. Well, I can't do this if b is 0. Don't know what to do, so I'm just raising an error. In other words, I'm letting the main program know that there was a problem. I'm alerting the main program.
So I just tried running it without the if else and just returned a divided by b.
Yeah.
And input 0, it did exactly the same thing. You can't divide by 0. It didn't.
I think you got red though, didn't you?
No.
That's because Python's raising an exception instead of us. Okay. So Python actually would raise an exception when this executes if we don't raise an exception. But it was just a simple example. We're raising the exception. The same.
So there's other situations where
There are many situations. Yeah, I'll do another one in a sec. Yeah. There's other situations where Python's not going to give an error that we want to raise an exception. Yeah, and we'll see one in a sec. Okay, so let's see. Yeah. So anyway, then here, right down here in my main process, there is someplace else where an exception might occur, right? Where else might an exception occur in this little main process? What about this int? Whenever you call int on user input to do a conversion, if the user gives you bad characters, Python will throw an exception, right? Python will raise an exception. So it might be nice. It might be nice to put this statement in the try block as well. Okay. And now I'm in the situation that I was in before. I have two different, I'm not quite in the situation I was in before. I have I'm in a similar situation. I have two exceptions that might happen, okay? But what type of exception will Python raise if the user enters an A? We just saw it in the previous program. A what? A value error, right? And what type of exception does divide give us if we pass a 0 to it? A value error as well, right? So I can't use two exception blocks like I did before to differentiate between the two errors, between the two situations. I can't do that. But what I can do, okay, what I can do is I'm going to say except value error, and I'm going to say as, as, and then I'm going to pick a variable name. Doesn't matter what I pick, so I'm going to pick X just to make that point. When I say except, and I give the type of error that I'm catching, okay, that I'm handling, and I say as, and I give a variable name, what happens is the exception, the exception that was that happened is stored in that variable. Because an exception actually is an entity, it's actually an object. Okay, it's an object that's created that's thrown back to the main program. So the actual exception itself is stored in X, and then rather than printing out a message, I'm going to print X. Now when you print out an exception, what happens is the string that is stored in that exception is what's printed. Now, so the exception that I raised up here, the string that's stored in it is the one that I put right here when I created the exception. When I raised the exception, I typed something here. That's the string that's stored in that exception. If I get an exception, a value error exception from the int, from calling int with something that isn't an int, Python puts some string in that particular exception. So it's going to print one thing or another depending on which value error exception is actually raised. So if we run this, let's try both of them. If I run this and hold on, I want this near the top. If I run this and I give, let's see, each element's going to be, each element in the list is going to be divided by something. I enter an A, okay? What happens is I get this particular string coming out. Okay, in other words, an error occurred right here in this line, okay? And the value error was thrown by the int function, was raised by the int function. And so we came back down here, that value error object is stored in X, and it prints the string that was in X, and the string that Python had put in there was invalid literal for an int, A. Okay, that's what Python had put in there. On the other hand, if I run it again, I'm just going to run it again. And this time I'll give a 0, okay? And so if I type in a 0, again, what's going to happen is my 0 is converted to an int, and then down here divide is called with a 0, and the exception that I raised is created. The exception that my function raised has this string in it, divide by 0 attempted. Okay, and so that is the string that's printed. Okay, so if you have a number of the same type of a number of exceptions that are of the same type, you can print out the exception itself in the message, and the exception will be different. Okay, does that make sense? Why we got if it doesn't, ask. Do you see why we got the two different messages? Is everybody getting the two different messages? Okay, I'm sure there aren't any questions. Again, the idea is pretty simple. It's a little abstract, but if you keep it simple, it's just a value error, an error is an entity. When you raise it, it's like sort of like it's sort of like we've created objects. So when we raised an exception, what we did was when we raised a value error, we basically created a value error object. An object, and that object is given back right there, so this block of code, and the try block saw that value error and said, oh, I'm coming down here to the value error, and I'm going to store that value error object in X. Okay? So when I print X, that value error object and whatever was stored in that name of the string that I put in it. On the other hand, if I typed an A here, and the int function couldn't convert A to an int, what happens is if we actually were able to look at the int function, the code for the int function, there's a statement in there, raise, if the characters aren't right, raise value error, and there's a string in it, just like we did it. That's what the int function is. We actually look at the code. And that function, that error is raised and it's thrown back to this block of code. The try block is waiting for it, and so try block says, value error coming down here, and it's stored in X, and it prints out the string that the int function put in its value error object. Okay, so it's just an object that was erased, just creates an object and conveys it back, and that object is stored there. It might have even been nicer or clearer if the syntax is X equals value error or something, because that's really what's happening. So that when I have to add that, whatever the error is that occurred is stored. And there is an entity stored in there, and I can print it. When you print it, you see the string that was put in it when it was created. So that's why depending on whether the error came from here or the error came from there, we get different messages because there are different value error objects, strings in them. And now let's see, because so now I think, yeah. Does this stay in here? Inside the try box. Okay. Let's see. So let me give you an example of, yeah, the divide one actually, it was logically simple, so I used it to show you how to raise an exception, but yeah, definitely, actually Python would have raised an exception itself when I tried to divide by 0, so I didn't necessarily have to do that there. But there are many times when you would actually have to want to do it yourself. Let's see if I can find one. Okay, I'll make one. Let's see, because it's a very handy thing to do here. Let's see. Let's see. I'm going to create a new file. Okay. Now, in a previous assignment, you made. Let's see. You had a class wallet, right? And you had, let's see, I'm going to keep it simple, but you had a init function, and let's see, and your init function initialized probably your your init function created a number of dollars and number of cents, right? And initialize those to the parameter values. And then you probably had, let's see, you probably had, because I don't remember exactly, you probably had an add dollars function. And your add dollars function probably did something like this. Right, and you had an add cents function, which probably did something like this. Is this looking familiar? Yeah. It should, okay. Okay, now, just again, I'm not even thinking about the main program that's going to use this yet. Now, looking at this add dollars method, function method, whatever method, it probably wouldn't be good. What add dollars does is it takes this amount of dollars and adds it to what's in the wallet, right? So it probably wouldn't be good if if this happened to be a negative value, because the purpose of the function is to increase the number of dollars. Matter of fact, it's probably not this function is not intended to reduce the amount of money in the wallet. It's intended to add the amount of money to the wallet. Okay. Now, so our first thought to protect ourselves from this might be if doll is greater than 0. Do this, else. Well, else I don't want to change the amount of the dollar. So my thought might be to print out can't a negative amount of dollars given, because this might be your first thought, how to protect your wallet from taking money out when you don't intend to, right? Now, and that's okay. It's not awful. Except the idea is, okay, this is called to put money in the wallet, and an error message is going to be given if this is called and money can't be put in the wallet. But actually, you really, really, really don't want to be printing out a message when you're doing this, okay? And when you're in a class, you don't want to print out a message from a class, because if you think about it, a class is intended to be able to be used by different programs. Remember, we put our class in a separate file, so one main program could use it if it needed a wallet, or a different main program could use it if it needed a wallet, or a third, that's the whole idea, reusability. This class can be used by different main programs. And we have no idea what's going on in the main program. The main program might have some very fancy thing going on the screen that might not want us spewing out some message like this to the screen. So typically, a method that's not supposed to be printing something, whose function in this case is just to increase the amount of money in the dollars, it wasn't intended to print something, so it shouldn't be printing anything. Okay, it shouldn't be, because again, the user interface could be something really, really nice. They could be building a table or something, I don't know, and then we're spewing out an error message, So there's something happened here. Okay, I'm writing this little function. My only job, when you write a method or a function, the idea is your only job is to just perform the task of that method. So the only task of this method is to do this. Okay, so if there was an error, if doll was negative, I can't do what I was supposed to do, which is increase the amount of dollars in the wallet. So what I need to do, so I don't know what to do. So when I don't know what to do, all I can do is convey the fact that there was a problem back to the user. So here, I'm going to raise a value error. I'm going to put a message in it. Okay? And I've handled the situation. Okay? Basically, when add dollars is called, if the parameter was fine, it happened. If it wasn't, I sent a message back. I sent an object back saying I could not add the amount of dollars. Now here, this is a situation where if I didn't do this, Python's not going to catch it. Python wouldn't know there was any kind of error occurring. So it's not like the divide by zero or Python's going to do something. Here, this was an error logically related to my own program. I would probably do the same thing down here and add cents, okay? And then in my main, I would do the same thing and add cents. So let me do it. So then, in my main, and I'll keep it in the same file just so it'll all be on the screen. But then in my main process that uses this class, right? I'll have a let's see, have a wallet object. Okay, and then, oh wait, I have to put money in it, don't I? $10.05, okay. And then, if I ask the user, let's see. If I ask the user to provide an amount of dollars, and then I call add doll with add dollars with my object, okay, I should get an exception. So I'm going to try to add a -5 amount of dollars, and I'm getting an exception, okay, and the exception that I'm getting here that comes up is the one that I threw in add dollars. Python didn't create that exception, I threw that exception, okay? And again, here's a situation where I threw it because it was necessary to have that in there, and Python wasn't going to catch it. And so, then what can I do down here? I can do just what we've done, just what we've done all along. I know an exception might be thrown, might be raised. I keep saying thrown because it's called thrown in other languages. Sorry, thrown, raised, same thing. Created, well, an exception might be created in either of these situations. Move that up. So I can put a try around it, and I can put a except around it. Matter of fact, both of the exceptions are value errors, so I'm going to assign them store them in a variable, and print out the variable. Okay, so I have I actually have 3 different error messages that could come out here when I run this. Well, 2, I guess, because I didn't call AdSense, but so 2 because I didn't call AdSense. But so if the user entered a letter, okay, it'll print out that a letter couldn't be converted to an int. If the user entered a negative number and that was converted, and I call add dollars, okay, that'll cause this exception to be raised, and I'll be printing out that message. So typically, I guess this is probably a long answer to your question, but typically if you write a function and it's absolutely essential that the parameter meets some specification. Like here I said this better be positive. I expect that to be positive. Okay, I expect this to be positive. Any function or any method that you write, if the parameter actually is expected to be something in particular, and the function or method won't work if it's not, then it should raise an exception, and that happens a lot. That's a way to protect yourself from bad parameters, and again, you don't always want to just be printing out error messages. It's better to raise an exception, okay, and then the main program can handle it, because the main program knows how to handle it. The main program knows what it's doing, what the logic is. Like right here, I could actually, let me think about it. Right here, I could actually, let's see. I wasn't going to do this, but I think I will. Let's suppose, let's see.
Object takes no parameters, and I cannot figure out why.
For which one?
When the money equals wallet 25. So object takes no parameters, but from what I can tell, mine matches yours.
I'm spelling it. What do you get? Okay, so actually something that we could do right here, right, what I've kind of been doing is printing out information if there's a try catch, but actually, if there's a try except, you know, if there's an error, but actually, let's suppose if the user either provided the wrong character or provided a negative number of dollars. Let's suppose we wanted to allow the user to do it again. Okay, and this is just another way of handling an exception, right? Another way of handling an error. So I'm going to do, let's do this. Because this whole scenario here is the idea is to add some money, right? So let's start out with, let's see, let's say okay equals false. Well, yeah, okay equals false. Oops. I'm just going to have this variable and I'm going to put false in it. Okay. And then let's see, how do I do this? Okay equals false, I'm going to say, or no, I'm sorry, okay equals true. Okay, then I'm going to say while okay equals true. No, wait a minute, I'm sorry, let me think this through for a minute. Let's see, so while okay equals false, I just want to, it'll work either way, but I want it to read well. So while okay equals false, I'm going to try doing this and this, okay? So if I do this, if I read in, I successfully complete this statement, $, equals int, and I successfully complete add dollars, in other words, no error occurs, I'm going to say okay equals true, okay? On the other hand, if there's an error on either of these statements, I'm coming down here and I'm printing out the error message. Now the effect that this is going to have, okay, is it's going to, well, okay, if these two statements successfully completed and the money was added, okay becomes true, we get back to the top of the loop, okay is not equal to false, and the loop's done. On the other hand, if either of these statements failed, we never reached this okay equals true statement, come down here, print the error, and come back up again, and it's going to prompt the user again. So this is, again, a different way of recovering, but it was the main program's choice to allow the user to enter a value, because typically all input and output should be done by your main process. So here, okay, amount of dollars minus 5. It's telling me negative amount. Now it's starting over again. Okay, so now I'm going to give an A. It's telling me, bad character. Try again. And then I give a correct value, and it goes out of the loop and continues on. Okay, so again, that's just one other way, just getting a little bit more complicated about it, but one other way to recover from something with your try except is to continue and to repeat, okay, until you get what you want. Okay, so we've seen 3 different ways of recovering: giving an error message, substituting a value, and repeating until the user provides some correct input. Okay. But again, the point at which we started all this was that we were writing two different methods, and the same thing goes for functions, where it was essential that the parameter meets some qualifications, and so if it didn't, what the method was, it erased an exception rather than just printing out an error message, and it left the decision of how to handle the situation, how to handle the recovery to the main program, which is the whole idea. Because the main program is where the logic is. A little function doesn't know where it's being called or how the main program wants to handle it. Okay, so is everybody up? Okay, so it doesn't work?
Yeah.
What's it doing?
Nothing.
Nothing? Is it just sitting, you mean?
Yeah.
I bet, did you put in that okay equals true part?
Yep.
Okay, let me just pause this. We'll have one more thing to look at. I'll show you one more thing. We're just gonna look at it. Let's see. Last time we had written some stuff with files, We had written some, well, actually, yeah, last time we had actually written some stuff with files, opening, closing files. And I talked about, and we'd seen that, you know, some files are expected to be there, you know? And I believe if you're opening, actually, it's not even the right file, hold on. But if you try to open a file that's not there, this is the one that I want. Let's see. If you try to open a file that's not there, okay, an exception is raised by Python. So right here, this program up here is trying to open a file. It's trying to open it for reading. And remember we said if you try to open something for reading, it's got to be there because you can't read from it if it's not there. Okay, so if there's not a problem if you go on with the program, and saw this last time, you try to read from it, it's not there. So actually, if you try to open a file and it's not there, there is an error that Python raises. Okay, we weren't trying to catch it before, so we didn't see it. But here, in this particular program, I asked you for a file name, I tried to open it for R, so I'm trying to open it for reading. Okay? I have that in a try block. So if an error occurred, which would occur if I tried to open something for reading and it wasn't there, if an error occurred, the type of error it's going to be is an OS error. Okay? And so I have an exception there for OS error, and I said, file is not found. Now, here's another little thing you can do. I haven't done it yet, but you can put an else after your except, okay? And you put an else after your except, basically what happens is your try block. If there's an error in your try block, you execute the except as normal, as usual, okay? If there is no error in your try block, you execute the else. So what basically happens here is if there was, I couldn't open the file, it's going to do that. It's going to handle that except block, it's going to handle it. And just print out error message, file is not found. On the other hand, if there was no error in the try block and the file opens successfully, it's going to execute this and read stuff from the file. Okay? And so that's kind of a common thing to do when you're opening a file for reading. Okay, check for an OS error and then do the rest in else. Okay, and then that way you won't execute this if there's no. It only executes this if there was no error. So the OS error. So Python raises the OS error exception. An OS error if they can't open a file. Okay, and that would be something, remember before, I think for the last program that you were writing, you had to open a file for reading, and I said, yeah, you're going to have to make sure that the file's there before you start, because we hadn't talked about how to check if it wasn't there or not. Well, this is how you check if it's not there or not. Try to open the file. Always try to open a file in a try block. Even if you're opening for writing, it doesn't hurt, in case there was an error with the file. Okay, and then if there's a problem, you can catch it. Matter of fact, this other example that I was about to show you. Here's another example of using another example. Here, I was opening something for appending, so I don't, if it wasn't there, Python probably would have created it. But if there was any kind of error happening when it tried to open a file, again, here I have the whole program. Another way of doing it. I don't have an else on this one. I have the whole program in my try block. Basically, if there's any sort of error with the file whatsoever, an OS error will be raised, and I'm just printing there was a problem opening or writing to a file, because the OS error will happen regardless of what you're doing with the file. Even if I'm writing to the file, that could occur. So you can check for file errors with your try except. Okay, so you didn't have this one. You don't have to type in or anything. I just wanted to show you. Basically, what I want you to submit for your lab this time is your that first file with the 4 different scenarios in it, and the second file with the with the divide function. Okay, as long as both of those run, that's all I need you to submit for your lab.